Time travel has fascinated humanity for centuries, appearing in everything from ancient myths to modern science fiction. But is it actually possible? To answer this, let's dive into the science of time and explore the most compelling theories that suggest how time travel could or couldn't work. What is time? Time is often described as the fourth dimension, alongside the three dimensions of space. Together, they form what physicists call space-time, a flexible fabric that can be warped by gravity and motion. Albert Einstein's theory of relativity revolutionized our understanding of time, showing that it is not constant. It can stretch, shrink, and even bend depending on the circumstances. This realization opened the door to the possibility of time travel. Traveling forward in time, a proven reality. Believe it or not, time travel into the future is not only possible, it has already been demonstrated, at least on a small scale. Einstein's special theory of relativity tells us that time slows down as you move faster. This phenomenon, called time dilation, has been confirmed by experiments. Example: astronauts aboard the International Space Station experience time slightly more slowly than people on Earth due to their speed and reduced gravity. When they return, they've effectively traveled a tiny fraction of a second into the future. Theoretically, if we could approach the speed of light, time dilation would become extreme. A person traveling near the speed of light could experience just a few years, while decades or even centuries pass for everyone else. This is known as the twin paradox, where one twin ages more slowly than the other when traveling at relativistic speeds. Traveling backward in time, the big challenge. Traveling to the past is a much more difficult and controversial concept. Several theories propose ways it might be possible, though each comes with significant hurdles. 1. Wormholes, cosmic shortcuts. Einstein's general theory of relativity allows for the existence of wormholes, or Einstein-Rosen bridges. These are hypothetical tunnels through space-time that could connect distant points, potentially even different times. How it might work: if one end of a wormhole is accelerated close to the speed of light and then brought back to its original position, time dilation could mean the two ends are in different times. Traveling through the wormhole would effectively allow for time travel. The problem: wormholes are purely theoretical. Even if they exist, keeping them stable and open would likely require exotic matter with negative energy, something we haven't discovered yet. 2. Time loops and closed time-like curves. Some solutions to Einstein's equations of general relativity predict the existence of closed time-like curves, CTCs, which are essentially loops in space-time. If you were to enter such a loop, you could theoretically revisit past events. Example: theoretical physicist Kurt Gödel proposed a rotating universe where such loops could occur. The problem: these scenarios often violate causality, the principle that cause precedes effect. This leads to paradoxes, like the grandfather paradox, where traveling back in time to prevent your grandfather from meeting your grandmother could prevent your own existence. 3. Cosmic strings. Cosmic strings are hypothetical, incredibly dense and thin structures thought to have formed in the early universe. Some theories suggest that if two cosmic strings passed near each other at incredible speeds, they could warp space-time in a way that allows for time travel. The problem: while fascinating, cosmic strings are speculative, and we've yet to find evidence they exist. The many worlds. Interpretation: escaping paradoxes. One way to avoid time travel paradoxes is the many worlds interpretation of quantum mechanics. This theory suggests that every possible outcome of an event spawns a new parallel universe. Example: if you travel back in time and prevent your own birth, you don't erase yourself. Instead, you create a new timeline where you were never born. In your original timeline, you still exist. The problem: while intriguing, this idea raises philosophical questions and lacks experimental evidence. Quantum time travel, a new frontier. Quantum mechanics, which governs the behavior of particles on the smallest scales, offers intriguing possibilities for time travel. Some interpretations suggest that particles can influence past events through a phenomenon called retrocausality. Example: experiments with particles like electrons and photons hint at behaviors that appear to defy traditional notions of time. Could these phenomena one day scale up to allow macroscopic time travel? We don't yet know. Thank you so much for watching our video. Make sure to subscribe to our channel and press the bell icon to get all the latest updates every day. We will meet you in the next video.